Hello guys, in this video I will introduce you the solution for LeetCode weekly contest 353. There are 4 problems with the score 3455. Okay, so now we start from the first problem that we are given two integers num and t. An integer x is called achievable if it can become equal to num after applying the following operation. 1 no more than t times increase or decrease x by 1 and simultaneously increase or decrease num by 1. Return the maximum possible achievable number. It can be proven that there exists at least one achievable number. So for this problem, it's quite clear that so what we should do is we should apply num by increasing 2 each time, because so for example, if we already have num and suppose we already know the maximum achievable number, then because we can increase the achievable number by 1 or decrease by 1, and also we can increase num by 1 or decrease by 1. So the smart way is each time we decrease the achievable number by 1 and increase number by 1 so that they are closer. And then at most we can do t times, so that means the gap between the num and the achievable is t by 2. So the solution is just like return num plus t by 2. And the second problem, maximum number of jumps to reach the last index. So we are given a zero-indexed array nums of an integers and an integer target. We are initially positioned at index 0. In one step, we can jump from index I to any index j, such that G is bigger than I, and nums J minus nums I is bigger than minus target, and it's less or equal than target. And we are asked to return the maximum number of jumps we can make to reach index I minus 1. So this is the example, like target is 2. So first time we can jump from 0 to index 1, and then from index 1 to index 3. So this is 1 and this 3. And from here, we may go jump to last index. Notice that we need to get maximum number of jumps. Okay, so for this problem, we can see the constraints of the nums lines actually is not big, it's just 1000. So that means we can use the solution of all square t, all square n. So this problem we can just resolve it in this way, that we get the nums size, and then we build another vector with length n, and initialize each element to be minus 1. So this value vector is used to persist the maximum number we can jump from the current position to the last elements. And initially we initiate the last element to be 0 because last element is no need jump, right? The target is the last element. So last elements has 0 jumps to last elements. And then we iterate the nums vector from end to beginning. And at each elements, we go to check all of the elements after the current elements, just like this. And if the checked elements, the value is -1, means from last elements, we cannot jump to the last elements. So we just continue. Otherwise, we go to check whether we can jump from current element to last elements. If we can jump, then we update current element's jump number to be max of current element of the maximum jump of current elements, and the middle elements, that is value j, and +1. +1 means we can have one jump from current elements to last elements. So in this case, we may get the maximum jump of each element and store the value in val vector. And last, we just return the first element's value in val vector. Okay, and the third problem, longest non-decreasing subarray from two arrays. We are given two zero-indexed integers arrays, nums1 and nums2, of length n. Let's define another zero-indexed integer array nums3 of length n for each index I in the range 0 to n-1. We can assign either nums1 or nums2 to nums3. Our task is to maximum the length of longest non-decreasing subarray in nums3 by choosing its value optimally. Return an integer representing the length of the longest non-decreasing subarray in nums3. So for this problem, actually, this is not really a difficult problem. So what we can do is, so first of all, we initiate answer to be 1, because we know that for non-decreasing subarray, right? So for each element, it build a subarray of non-decreasing. So answer will be at least 1. And we define another two values, v1. v1 means at each element get the maximum number, the maximum value of nums1 and nums2, and v2 is the maximum number between nums1 and nums2, and n1 and n2 means the non-decreasing subarray of v1 and v2. And with this initialized, we just iterate the nums1 and nums2 from 1 to n-1, and each time we go to get the temporary v1 and the temporary v2 as the maximum number between nums1 and nums2, and the tv2 is the maximum number between nums1 and nums2. And then also we initiate temporary n1 and temporary n2 as 1, and then we go to check whether tv1 is bigger or equal than v1. If it is, then we update to n1 as the n1 plus 1. So this makes sense, right? So because this tv1 is bigger or equal with the n1. So that means we can use nums1 to continuously build non-decreasing numbers. So tn1 should be n1 plus 1. And also, if tv1 is bigger or equal with v2, we update tn1 like max tn1 and n2 plus 1. Similarly, we go to update tn2, and answer will be updated as the maximum tn1 and tn2, and also maximum with the current, compared with the current answer's value. And then we update tn1, tn2, tv1, tv2 to n1, n2, v1, v2. And finally, we update answer again, and we may get the final answer. Okay, so this is the third problem. And the last problem, we are given a zero-index integer array nums and a positive integer k. We can perform an operation on the array any number of times. Choose any subarray of size k from the array and decrease all each element by 1. Return true if we can make all the array elements equal to 0 or false otherwise. So for this problem, we can think it in this way. Let me draw you something to explain the idea. So for example, we have this array like nums0, nums1, nums2, nums3, nums4, nums5, nums6. For example, totally we have 7 elements in the array, and let's say k equals 4. So that means we need select a subarray of length 4 and minus 1 from each of the elements in that subarray, and at last we need all of the elements in this array equal 0. So let's suppose the first element is bigger than 0. So we can check that for first element, right? It must be because we need this element to be 0 at last. So that means we must minus this by its current value. So what I mean is, for example, this element is 5, because we need it to be 0. So in that case, we must minus current elements 5 times. Okay, so this will change from 5 to 0. And because this is the first element, so we have no option to select subarray to select any elements before it to build the subarray. So the subarray actually is fixed to be the first 4 elements, right? And this must be come to 0. So we must minus it by 1 for 5 times. And similarly for these 3 elements, that means we also must minus them by 5. So all of these 3 elements must minus by 5. And then first element will become 0. And then we go to check each of the 3 elements, and they must be bigger or equal than 0. If they are smaller than 0, for example, if the second elements become -1 now. And because we can only minus 1, so that means these elements cannot become 0 again. So in this case, we can return false directly. So that means if we want to get true result, all of the three elements must be bigger or equal than 0. So all of the three elements will be bigger or equal than 0. And now the first elements become 0, so we can we no longer consider the first elements. We can start from the first elements and do the same thing. So this is bigger or equal with 0. So if it's 0, then we just ignore it and jump to the next elements. But if it's bigger than 0, so we will do the similar thing like the first elements. We will select from the first elements and go to check the next 4 elements. So that means elements from 1 to 5 and do the similar things. So in this way, we can find we need all of the elements to meet one requirement select. For the first 4 elements, they must be non-decreasing. So that means they must be like this. So each element must be equal or bigger than its previous elements. Otherwise, it will become, if we change some elements to be 0, then the elements after it will become minus value. So that means we can return false. So to return true means the first 4 elements must be non-decreasing. And after we minus the first elements from the first from elements from 1 to 3, and now we need so these 3 elements has new value, and then now we include the first elements, and also these 4 elements must be non-decreasing again. But remember that for the first 3 elements, they already minus n1, n0, right? So each element now already minus n0. And that means if we don't consider minus n0, but we consider their original value, so we must plus n0 to the fourth element. So this can plus n0. And that means n1 should be smaller or equal than n2, and n2 should be smaller or equal than n3, and n3 should be smaller or equal than n4 plus n0. Okay, and then similarly, we can consider the next elements n5. So n5 should be like n5 plus n1, right? So in this way, we can find so first of all, for the first 4 elements, they must be non-decreasing, and each time we will plus this element to the next elements with length of k. So here means we plus n0 to n4, and still need these 4 elements to be non-decreasing, and then we add n1 to n5, and then require n2 to n5 now to be non-decreasing. So that means in this way, we can always make the first elements to be 0. And we can do this so and so and so, but for the last 4 elements, finally, they must be equal. Otherwise, they cannot become 0 at the same time. So for this problem, solution is just like, first of all, we go to check the first k elements to make sure they are non-decreasing. If they are not non-decreasing, then we just change is good to be false, and then we return false directly. Otherwise, from the k's elements, actually this is k plus 1's elements, that we always update the current elements with the elements like k's before it. And then we need to check the current element's value then should be bigger or equal with its previous elements to make sure they are non-decreasing. Otherwise, we change is good to be false, and then we also break here. So if we check some elements cannot meet this rule, then we can return false directly. Otherwise, that means all of the elements meet the requirements, and then we go to check the last case elements. Now they should be equal, and if they are not equal, we also return false. Otherwise, means we are good, so we can return true. This is the solution for the last problem. Okay, guys, so if you have any questions or comments about the solution of the problems, please let me know. Thank you.